Hello, good morning, students. Today I am going to teach topics of amines. In previous lecture, we learn about the physical properties of amines. In that, you learn so many physical properties regarding that basic strength of aliphatic amines and aromatic amines means arylamines that we want to learn today. Last time I gave one table. Same table we are going to continue because that table includes the information about the standard formula as well as their pKb values and with the names of the amines. Students, in the basic strength of aliphatic and aromatic amines, about that, I gave last time one table also. The table containing three columns of amines. Second one is structural formula and its related pKb values. About that, I explained which is the most basic, which is the most acidic. About the basic strength, normally basic strength of the amines primarily we learn the role of nitrogen in that compound. You know, the types of amines are three types: primary, secondary, and tertiary, and the basic origin from the ammonia that can be represented. Their order of the pKb value that can be represented from above table is that amines is amines has greater value pKb value than that of the primary amines RNH2, then which is the greater value than that of the R2NH. Now here this R2NH has the greater value than that of the R2NH has the less value as compared to the tertiary amine, and the order of basic strength is ammonia less than primary amine less than secondary amine less than tertiary amine. Secondary amine has greater value than that of the tertiary amine. So these orders are about deviating, and the observed pKb values of the aliphatic amines, secondary amines indicate that these are the strongest bases. So from this also we can determine their basic strength, and the basic strengths of amines increases from ammonia to the primary amine and from primary amine to the secondary amine, but the basic strength decrease from the secondary amine to the tertiary amine. So it is what abnormality. This why this abnormality or why this differentiation is there, that we can learn on their stabilization order. Greater the stabilization of the conjugate acid. Now what is the conjugate acid? From the base by loss of proton or electron, what are things remain, that is called as conjugate acid. That I already said last time. Same will continue for this theory also. Greater the stabilization of the conjugate acid indicates more which can be shifted right side, the equilibrium will lie, and the stronger will be the base and small will be its pKb value, that we can learn from that table also. After all, greater is the stabilization of the protonated amine means conjugate acid, greater is the basicity of the amine. So from that previous table you can clearly understand that this order about the basicity as well as their pKb value from this table you can understand better. So everybody has to see this table very carefully. Then basic strength of aliphatic amine that can be depends upon basically three factors. First factor is influence of the plus effect. Second factor is influence of the solvation. Third factor is combined influence, which can be explained as below. In that first factor, I want to explain influence of positive inductive effect. Inductive effect is the basic character which can be indicates the polarization of electrons, and that can be observed in case of polar bonds. Influence means the role of inductive effect about the plus I groups. Plus I groups means the groups which are electron donating, that can be decided the influence of plus I effect on stabilization of the conjugate acids of aromatic amines and ammonia, that we can represent as shown below. In this structure, you can observe that here NH4 plus means positive charge is over the nitrogen atom. Here, in case of second structure, RNH3 plus, in that means one hydrogen atom that can be replaced by one alkyl group. Alkyl group has the electron donating capacity or tendency. As the number of the alkyl groups are increases, electron donating capacity toward the central nitroatom of these amines is also increases. In second structure, we will observe that there is only one alkyl group. In third structure, we will observe that there are two alkyl groups are there. Then in third structure and last in that R, R, R means what three alkyl groups are there which can be attached to the central nitroatom. Obviously, as the number of the alkyl groups are increases, the positive effect also increases. So from this we can understand that an alkyl group exerts electron releasing or inductive effect plus I, which can be stabilize the positive charge on atom which can be bonded to it. Of course, central nitroatom is electron deficient now due to positive charge. It has need of electron, and that electron can be supplied from the neighboring alkyl groups. That's why as the number of alkyl groups are increases, shows the stability increases, shows the plus I effect also increases. As we move from conjugate acid of the ammonium ion NH4 plus to that of tertiary amine R3 NH plus, the number of alkyl groups are bonded to the nitrogen atom goes on increasing steadily, and that's why there is increase of the stabilization of the conjugate acid, and thereby an increasing order of the basic strength is expected. So this is the natural phenomenon. As the number of alkyl groups are increases, their stabilization also increases, means stabilization of conjugate acid also increases, and the basic strength of the amine also increases. The order of stabilization is that ammonium ion has less order than that of the R. Ammonium ion has less order as compared to RNH3 plus, less than that of the secondary amine R2 NH plus, less than that of the tertiary ammonium ion R3 NH plus, and the expected means observed basic strength is somewhat different, that is of ammonia is less than that of the RNH2, less than that of the R2NH, less than that of the R3N, and the expected order of the basic strength on the basis of number of alkyl groups, of course on the basis of plus I effect, that can be shows differentiation from the observed value. That's why this two contradictory things suggest that rather than the stabilization, there are some effects are going to work on the stability, on the basic strength of the conjugate acids of the amines. And that's why two more factors we're going to discuss now. In that, second factor is influence of solvation. Solvation, you know that whenever any compound, if you're going to mix with solvent, that can be dissolved and that can be form the property of solvation. In that, influence of the solvation by water on stabilization of the conjugate acids of aliphatic amines with ammonia, that better we can explain according to this four structure. Structure number one, this is structure number one, then this one is the structure number two, then this one is the structure number three, Then this one is the structure number 4. So from this 4 structure, we can observe that the central ammonium ion NH3 plus that can be bonded to the this water molecule, this water molecule, this water molecule, and this water molecule. Four water molecules are attached to the four neighboring hydrogen atoms of the ammonium ion. So there is bonding between oxygen as well as bonding between hydrogen. Bonding between oxygen of water molecule and bonding between hydrogen of ammonium ion. That bonding that can be shown by dotted manner, and that dotted manner indicates that there is not presence of hydrogen bonding. Of course, this bonding is called as hydrogen bonding. Here this hydrogen bonding, this also hydrogen bonding. Here also we see, and here also we see a dotted portion called as hydrogen bonding. In second structure, in that RNH3 plus that can be bonded by three water molecules. So here one water molecule that we can replace by R. In third structure, R2NH plus that can be bonded with the 1, 2 water molecules, and in last structure R3N plus that can be bonded with the only one water molecule. You know that through the central nitroatom, as the number of hydroatoms are decreased, so in that way as the number of water molecules are also decreased, and these hydroatoms of the ammonium ion that can be replaced by respective alkyl groups, and that's why solvent water whenever we are going to add, so addition of water molecule indicates that it shows stability to the conjugate acid by hydrogen bonding through the hydrogen bonded to the nitrogen atom, and that bonding is clearly shown in all these four picture by dotted manner. That's why the number of hydrogens bonded to the central nitrogen plus that can be decreased from 4 in ammonium ion toward the 1 in the R3NH plus ion. Of course, you observe that in case of quaternary ammonium salt, there is what presence of the or quaternary ammonium ion in that 4 hydrogens are present on the central hydrogen. Then as per the structure number 1, 2, 3, 4, if you are going to see in that number of hydrogens which are bonded to the nitrogen that can be decreased and that can be replaced by the alkyl group. In that way we are going to use the water molecules. So here as a result, as the ammonium ion is the base stabilized by solvation by addition of water molecule, while the stabilization by the solvation is very poor in case of R3NH plus, and that we can learn from the first structure. Now third factor we can discuss about the combined influence. Influence means what forcefully we can say. Here combined influence of the plus effect and solution of the stabilization of conjugate acids of the aliphatic amine like primary, secondary, tertiary, that they can be decided the observed basic strength of the pKb value. pKb value decides about the basic character means basic strength. That's why this pKb value table we are going to study priority. Then these two influencing factors that can be operate in the opposite direction. So how they can be operated by the opposite direction? There is role much more great role of the solution with their corresponding positive inductive effect. Here this order is what you may say inversible, or you may say it is what reciprocal order. As solvation decreases, plus a effect increases. How it is? Because in case of ammonium ion, there are 4 hydrogen. In case of RNH3 plus, there are 3 hydrogen and 1 hydrogen of the previous one that can be replaced by one alkyl group. As the NH4 plus, RNH3 plus, R2NH plus and R3NH plus, in that as the number of hydrogens are decreases and the number of alkyl groups are increases. In previous slide also I said that as the number of hydrogen atoms are decreases, the positive inductive effect means plus I effect is what increases, because alkyl group has the electron donating capacity or electron donating power, you may say. That's why plus I, if it increases, solution power is what decreases. So this reverse order or inverse order you have to remember. Later on, the net result is that as we move from ammonia to the RNH2 to R2NH, the basic strength increases due to better stabilization of corresponding conjugate acids of these amines. But in case of tertiary, it is weak base. Why? It is weak base than that of the secondary amine. The reason is that the stabilization of the conjugate acid of the tertiary amine by solvation is very poor, and that's why such type of abnormality we are going to see over here. I explain these three factors in case of this basis or basic strength of the aliphatic amines. Now in same way I want to explain about the aromatic amines, or you may say aryl amines as per the title. From the pKb value table we can understand that the aromatic amines in general are weaker bases than that of the ammonia and aliphatic amines, because strength of aryl amines is explained on the basis of Lowry and Bronsted theory by writing the following equilibrium. Equilibrium means you know that forward and reverse order of this reaction in that rate of the both reaction means rate of forward reaction becomes equal to the rate of the reverse reaction. That is called as equilibrium, that we learn in the 11th standard. In that, what the amine on the benzene ring NH2, on the nitrogen there is lone pair of electrons, and the compound in that the atom which has the lone pair of electron, so this lone pair of electrons is easily donated to the neighboring molecule or atom. That's why ammonia is what base, you may say Lewis base. In that, by addition of water molecule, it shows equilibrium and it gives on benzene NH3 plus positive charge, of course, on nitrogen plus OH minus ion. Here NH3 plus ion with benzene is called as conjugate acid of this base. I said whenever any species related with donation or acceptance of proton, that time the things remain from that base is called as conjugate acid. That's why the conjugate acid is obtained from this base. So conjugate acid of the aniline that we can show in this diagram with loss of OH minus ion, that you have to understand better. Then here both the species base and conjugate acids are resonance stabilized, but to the different extent. So what kind of extents are this one, that we are going to learn in next slide. Before that, we'll see aryl amines in the primary amine means NH2 group that can be attached directly to the aromatic ring. On the benzene, here NH2 group is directly attached on the aromatic ring, that we can explain over here, and that's why in this lone pair of electrons on the nitrogen, this lone pair you can observe, lone pair of electrons on the nitrogen that can be conjugated to the aromatic ring and is less available for the protonation. That's why aniline is resonance stabilized by the following resonance structure. And normally we are going to see there are 5 resonance structure of this aniline. First structure that we'll see, aniline on the benzene NH2 group is there. In that this lone pair of the nitrogen that can be transferred to the single bond which can be joined to the benzene, and here the neighboring double bond, in that what the pi bonded electron that can be shifted to the neighboring carbon of the benzene. So here these electrons are shifted to this position. That's why at this position in next structure we will see the negative charge or negative charge. Nitrogen donates electron, that's why nitrogen acquires positive charge. Here we will get double bond, and at this side we will get the negative charge. Now this negative charge means what, electron reach point or electron reach center, you may say. From these electrons are shifted from this position, and later on these double bonded pi electrons are shifted toward this one. Why only pi electrons are shifted? Because pi bonds are weak bond, and those who are weak has the ability to donate electrons earlier or easily as compared to sigma bond, because sigma bonds are stronger bond. So here pi bonded electron means weak bond electrons are easily shifted. Then this in third structure, these negative charge electrons are shifted to this position, and the double bond electron pi electrons are shifted to this position. And in next fourth structure, these negative charge electrons are shifted to the single bond, and from this double bond electrons are returned back to the nitrogen atom. And the fifth structure will get on benzene NH2 with lone pair of electron. The difference of the first and last structure is that both structures of the aniline, but difference is that this last structure is obtained by the delocalization of the electron, especially pi electrons. Okay, that's why such type of effect we'll see in case of aromatic amine, means that we'll see in case of aromatic compounds of the amine. On the other hand, anilinium ion that can be obtained by accepting proton, and they does not have lone pair of electrons on the nitrogen atom. That's why they can be stabilized only by two resonance structure. In that, these both resonance structures are less stabilized than that of the aniline compound, that you have to remember. In case of on benzene NH3 plus means anilinium ion. Now this anilinium ion, in that electrons are shifted only among the ring, they are not reach up to the nitrogen atom. Now these pi electrons are shifted over here, these pi electrons are shifted over here, pi electrons shifted over here. That's why there is changing of the positions between the pi electrons, this one, then pi electron this one, then pi electron this one. So these three positions were shifted over here by this arrow, and this structure second structure we can get in this manner. So here what are the anilinium ion, we'll see these both anilinium ion means structure number 1 and 2. These both are what? Resonance structures, and these are what less stabilized as compared to aniline. From this you can understand that in case of aniline there are 5 structures totally, and that we can see by shifting of the electrons in that involvement of the nitrogen, but here there is no involvement of the nitrogen. That's why these are what less stable than that of the aniline. So this is the basic reason. Later on, as a result, the equilibrium shifted toward the left side, and it makes the aniline and also other aryl amine which are weaker bases than that of the aliphatic amines as well as ammonia. Sometimes they can ask in the scientific reason also. So about in that way you have to prepare. Students, today I explain the basic nature or basic strength of the aliphatic amines as well as aromatic amines, that you learn well better by revising the topics, as well as how electrons are shifted and what is the theory behind the sigma bond, pi bond, sigma electron, pi electron, as well as you have to learn the what the transfer of the electrons among the ring as well as outside the ring with the neighboring or attaching atom or element, that also you have to learn. And these mechanisms are very important as for concern of your board exam. Remember this one. You have to better revise this topic 1 2 times. On these topics, will arrange tests also for the topics I taught till today. About that, I will arrange tests also. Clear? Okay. So students, uh, everybody has to remain stay safely in house. Stay safe. Stay in home. Take care. God bless you and thank you.